All right, good evening. Good evening, everybody. How is it going? Welcome to the second ever Taco Tuesday. Let's talk about it Tuesday. For those unfamiliar, anyone listening to this that might be unfamiliar with Taco Tuesday, this is just a segment without gaming, so typically most of my content is with gaming. Sorry, I did not mean to hit that button. Perfect. Typically, I do most of my segments or most of my streaming with gaming, and I decided that I do want to have kind of some space to talk about science education, learning, and just things in general. Whoa, that is a little... There we go. There we go. There we go. Okay. So sorry about that. So I decided I wanted to have a space. I wanted to create a space where eventually when there's people here in the chat rooms, right now I'm just recording to an empty room, which I'm totally happy to be doing anyway. But I wanted to have a space without gaming to just really allow people to interact or just really allow us to concentrate on focal points here. Because I do acknowledge that while I'm gaming, even though during gaming I always mention that I'm super happy to talk about science, education, anything like that, I'm always I acknowledge that maybe a viewer might feel either like uncomfortable asking a certain question because I might not pay full attention to it, which if people do ask me questions and it's not about the game or anything, I usually do stop doing what I'm doing in the game to answer the question because I do like to give it thought to my answers. So, but I do acknowledge that having that gaming going on can be cool. And can establish kind of that fun environment. I get that. But at the same time, can also be distracting. So why not open up a second type of stream within a stream, if you will? Why not open up just kind of chat rooms dedicated solely to the discussion? And since right now it's basically just me broadcasting to an empty room, I'm mainly picking the topics, but eventually it'd be really cool if people were here and interacting with me and stuff, that we could just talk about anything. It doesn't have to be what I chose. So Taco Tuesdays is intended to be this laid back, with music kind of thing. I can always stop music if people really aren't enjoying it, but laid back, talk with a grad student, ask me questions, whatever you want. Talk about anything really. Like I want to talk about traveling, maybe someday or something, during a different segment. I'd like to talk about like culture, stuff like that. It doesn't always have to be scientific or educational in the sense of like school and college, but educational in terms of just learning about our world. I'm all for it. So that is the contrast between Science Fridays, where I will be just talking basically about mainly about science and things happening in science. As a graduate student, I do get to attend a seminar or like a talk or a lecture every Friday given by a guest researcher from different universities across the whole world. And so I just thought it'd be kind of cool that we can build on what they're doing, like kind of have a discussion about that current research every Friday. So the difference there is that every Friday it's going to be a little bit more formal, a little bit more focused on science. Tuesday's open to anything. For now, I'm going to be deciding on the topics, but in the future, it'd be cool to kind of have some open discussions too. We'll see where it evolves. No one ever knows. A little bit of background before I begin with how research is done, because this does tie into how research is done, and I feel like I need to give a little bit of background about myself, so people can kind of see that I'm not just going based on what I see on television and assume how research is done. Like I am in the active process of doing research. I am doing my dissertation right now, which is basically like I have to do a lot of research in one go and kind of present it and defend it and do a lot of stuff. And I'm really happy to have a segment on dissertations, what they are, because I'm literally in the middle of the process of doing a dissertation. Wait a little sure. The recording isn't going to be ruined because of that. Okay. So a little bit of background of myself before I begin on how research is done. So I am a fourth year graduate student, which means I've kind of already been through 3 years of graduate school. My graduate program was what's called a like a master's in passing or like a 5-year PhD program. So I applied with having 2 bachelor's degrees. I got 2 bachelor's degrees while I was an undergrad at Arizona State University. My first bachelor's degree was in psychology, and my second bachelor's degree was in biology. And both of those are bachelor's in science. And then I applied to graduate school, and in my first 2 years, you're kind of building. You're just doing your overall plan is to get the PhD, but within your first 2 years, you're passing certain number of exams and what are called like quals or qualifiers. Um, and then you do like a thesis. You defend that in front of a committee of people. If you pass that, you kind of get your master's. But you applied for a PhD, so basically you just keep going. You don't like have a formal ceremony or anything like that. Um, so anyway, so right now I'm in my fourth year, so I've already done all of that. I already had to write up a master's thesis, do the you don't have to run the study, but I've already had to do the literature review, present a theory, how it would tie in, and basically propose a research design for it, and then have my theory and my ability to write be tested and questioned by a panel of scientists who already have doctorates and are experts in the field. So I've already kind of been through all that. I am doing my current degree in and neuroscience, so we just kind of call it in what's called social perception, or kind of like we like to take into account many different factors into our questions, but a lot of our questions are focused on social psychological aspects or social interactions or things about our lives that are kind of social. One prominent theory in our lab would be, just to give an example of what kind of theory we're talking about within our lab, would be something called social identity theory. It's this theory that posits a lot of our self-esteem, pride, ego, whatever, is not actually just derived from just ourselves, but from the groups we belong to. We can take pride in the groups we belong to. So you can think about maybe your high school years and how people really like to be in varsity. That's a group membership that gave people a sense of pride. And there's a lot of factors that go into what constitutes a group, what would make you feel great, what would make you feel horrible, intergroup dynamics. So our lab is really interested in intergroup processes, intergroup conflict. So this, in layman's terms, would be known as kind of like racism. It's kind of like an intergroup conflict. So what gives rise to racism? Why does it exist? What even is it? How is the brain doing it? So we also address neuroscience. So our lab likes to use MRI scanning or fMRI scanning, EEGs. We just got a couple of EKGs in the lab, but due to COVID, we haven't actually gotten time to use some EKG stuff. But we were really wanting to use those EKGs and doing other biological assays to kind of measure like enzymes and stuff present in the body, so we can get a nice picture of the mind and the brain, if you will. The mind being the psychology going on, the thought process, the cognition, so the cognitive psychology, and the brain part getting the enzymes, the biological function, and the brain behavior and stuff like that. And we can get a nice picture of a complex situation like a social behavior, because social behavior is extremely complicated. So that's just a little bit of background about myself. So I am in dissertation phase right now. So basically, I'm just sitting here reading a lot of literature about a very specific topic. My topic right now, one of the literatures I'm reading into a lot is attribution literature, and I'm happy to talk about that if anyone has any questions as to what attribution literature is, what attribution means and stuff like that. But that's not today's topic. Today's topic is how is research done? So this is coming at you from a fourth-year graduate student. Now, I'm going to be talking in a very more relaxed manner. This isn't intended to be a lecture. No Taco Tuesday will ever, nothing on my channel is intended to be a lecture. It's not intended to bore people. I'm trying to make this a fun atmosphere. I'm trying to make this live. That's why I have gaming involved. But with that being said, just remember, I'm not sitting here saying I'm the expert in these things. I'm just a graduate student trying to make it through grad school and opening a door to anyone that has questions for a graduate student. So I'm not an expert in my field yet. I don't have my PhD yet. So please don't get ahead of me and take every word of mine as if I know absolutely everything. I share a lot of my experiences and a lot of kind of what's going on around me as a graduate student, and I love relaying the science too. Now, that being said, I do have some expertise, right? I do have my bachelor's and my master's degree, and I've been in graduate school listening to a lot of research. So I do have some merit to my word when it comes to the science. But I do like to also talk about my opinions or my experiences, which that doesn't really need data, so to speak. This is just my experience. But again, I like to talk. I'm going to talk in a very, I'm going to try to keep it in a very relaxed manner, not a serious, stressful manner. This is why music's going and stuff like that. That's why I like to have little tacos and like sharks over here, and stuff like that. So the chat is active at any point. Anyone that wants to have a conversation, anyone have a question, comment, clarification question, anything like that, wants me to slow down, speed up. I don't know how it would speed up, to be honest. But anything like that, repeat something, I'm happy to do it. So the chat is active. That's what that big box right there is doing. If we need to pause music, let me know. Okay. So how's research done? So first of all, you need a question. And it needs to be a valid question. You can't just show up with any sort of question and expect to be able to do the research on it. There are realistic constraints on research. In an ideal world, yes, it would be awesome to answer any question, but that's assuming you have infinite resources, and one of those resources is time. But another resource is obviously money. It requires money to do research. So basically, I'm going to begin talking about research in the sense that you kind of already have your question, and I can pose a very simplistic experimental design or research question if we want, and I can use that as the example. But when I mention this example, just know that this is for the sake of simplicity to explain a process that may otherwise be harder to explain. So I'm just going to put it into simple terms. This type of experiment would probably not actually fly in the real world. Because either it's already been done. I'm trying to think of an experiment right now. It's whether it's already been done or it's just too simple that obviously. But so I'm trying to think of an experiment. Let's say you wanted to test whether summer drives sales of ice cream, right? So I chose that because it's intuitive that you could think, okay, summer means hotter, assuming you live in the northern hemisphere, of course. If you're living in the southern hemisphere, I'm sorry, my friends, just I guess inverse this example. If December months drive ice cream sales. So let's just say during the summer months, we're not going to say whether it's June or December. So during summer months, ice cream sales go up. So you predict that, yes, as the summer approaches, ice cream sales will start to go up and they will be at the highest, at the hottest temperatures. So how would one go about actually testing that and going through with this whole research thing and I'm going to give the process while being at a university. And this might not be the case for private sector. I haven't worked in research in private sector. I don't have experience there. So I'm speaking on behalf of a graduate student at a university and not on behalf of all research. Now, I do assume that there's a lot of consistencies in the way it's done, because if anyone's following the scientific method, well, we have to follow specific steps, of course. But the nuances is where I'm talking about that might be a little different. But I'm going to talk about it on behalf of a graduate student at a university. So basically, you would, if you are the graduate student, you would pitch the idea to your advisor. You would go to your advisor, and if you're not familiar with what an advisor is, it's kind of like your boss in graduate school, but more like, not a boss, but more like a mentor, because you get one of the challenges of graduate school is having discipline, because you get a lot of freedom, more than a lot of people think. That because some people may interact with grad students, and we always look stressed. We're like, oh, we're so busy. It's because sometimes we just mismanaged our time, because you have to manage your time. You have to be very wise about it, that we kind of mess up and we have to we're on makeup time or something like that. Sometimes it is the case that we're extremely busy, and that's just life. So basically, your advisor is like your mentor. So they are someone that had to go through graduate school, so they already kind of know what it's like. They know what you're going through. They know where they fell, where they succeed, and stuff like that. So they're they're going to try to help you. And I'm really happy to have another Taco Tuesday about applying to schools and stuff and choosing your advisor and things like that. There can be a process to choosing your advisor. You don't have to do the entire process, but I personally recommend doing some research on your advisors and stuff before you go apply to them. But basically, it is someone you choose. It's not like you're forced to be with an advisor for most cases. So your advisor is basically a mentor to you and helps guide your research. So you basically apply to bosses that have similar interests as yours. If you don't have an interest, then you're going to read about a lot of research, and maybe the one that sounds most interesting to you, that's where you apply. So a lot of the times, graduate school, you do apply to the grad school, but you're also very much interested in who you're applying to. So sometimes who you're applying to outweighs the name of the school. A lot of people might be interested in I want to go to this school because it's got a great name. But sometimes there's a way better researcher at a no-name school, and it's just better for you to work with that person, for example. Sometimes it's not, sometimes it is. A lot of cases vary. But so I'm just trying to give some background on who your advisor would be. So with my advisor, for example, I did read their bio, I read their research, and just kind of found that a lot of their interests aligned with mine. So I reached out, and that's how I started my connection with them, my relationship with that advisor, my professional or academic relationship, if you will. So your advisor is like your boss. They're the ones that have the funding for your lab. So if you're the graduate student trying to design an experiment, you kind of need funds to run it. So it requires some research, depending on your design, can cost a lot. Some of it can be very cheap or even free. But nonetheless, you're going to need participants, a method to recruit participants. You're going to need materials, most likely. You're just going to need a lot of stuff. So an advisor is kind of there to be that provider for you too. So a lot of the funding is coming out of your advisor's funding, because they probably have grants, or they probably have just funds for research. And so you're going to be using some of their funding to do the research. So the step one in doing research, after you've already developed your question, and I've done some streams on the scientific process and how what a research question actually is. I'm happy to have another Taco Tuesday, and really quick side note, at any time I'm really happy to deviate topics. We don't have to stay on the topic that the title says above me, or to the side, wherever. We don't have to stay on the topic. We can completely deviate if you have a burning question regarding a completely different area. We can go anywhere we want. Doesn't matter. Okay, so yeah, I had a stream on like how like asking a valid question, stuff like that. I talked a little bit about validity and reliability and stuff like that. And I'm happy to have another Taco Tuesday, or a Taco Tuesday regarding the scientific process and asking questions, kind of like the more correct way, um, or in a valid way. So this chat's about assuming you've kind of already done that, and you go to your advisor, you present this idea, and they agree, and they're like, okay, so let's do it. So then where do you begin? So you have to write up. So assuming you already have all the funding and everything like that, and if you don't, then you have to write up a proposal. So you actually do all the literature review, which is basically you do like a quick, not a quick, it's actually quite extensive. You do like an extensive research of the topic just to make sure it hasn't already been done before, because if it has, then why are you going to reinvent the wheel? Um, and then you kind of report what's already been done, and then how your research is different and how it's going to add in a beneficial or impactful way to society or to science or to something like that. There has to be a reason behind doing something. So not everything is going to be approved by either your advisor or the next step, which is the internal review board, the IRB. So basically, let's just say you've already gotten your funding, you're already good to go, and we're going to talk about how research is done from the beginning, like after you've already gotten approval and all of that, all the bureaucracy is already taken care of. So your first step is sending it to the IRB. So basically, you send them your design, how many participants you want to do, your risk analysis. You have to state all your factors, like, okay, this is where we believe can be risk to our participants, because the IRB was established to prevent a lot of inhumane things from happening to participants or to animals. There is like an IRB for animal studies as well, even though some animal studies do end in like you need to dissect the rat, for example, so they do end in death. But the IRB is there to make sure that the animals are put down in a humane way or in the way that causes the least amount of pain. So for us, for human research, we have the IRB, and basically we have to report to them where we believe may be a risk to them, but we also report benefits, like the benefits of the study overall or to the participant. Usually to a direct benefit to the participant is usually very minimal, but we say like how the research can impact the greater society and things like that. So we basically have this website where we fill in a lot of forms, and you're just sitting there like, okay, I want to recruit this many people. It asks, are you going to pay them or not? How the participants are being compensated. You have to upload all your forms, your consent forms. Consent forms are the form you have to give your participant before they do any experiment. They have to agree to do it. Otherwise it would be illegal. We cannot perform an experiment on someone that has not given consent. So I've heard attacks on science where they say we do a lot of illegal stuff. No, we don't. We are we're under a lot of scrutiny. If we do anything wrong, slip up once, we can lose a lot of funding and your career is basically gone. So it's not worth it. So plus we're not in science. A lot of scientists aren't in it to abuse people. They're trying to actually improve humanity and science. So they would already be against it to begin with. So many scientists would already be like, they wouldn't even design an experiment where it could possibly put a human at harm. Let me just get that point out there. But the IRB is like a panel of like 5, or it could be, I don't know how many scientists, but it's other scientists that review the experiment, and they say, okay, this sounds very harmful or potentially harmful to the subject, so no, or do these changes. They'll send you edits and stuff. So you're just uploading your entire experimental design, how you're compensating the participants, the consent form, and the debrief form. So the debrief form is something you also have to do. If you don't debrief a participant, you've done something illegal. And the debrief, so basically the consent form is going to present to the participant what you're about to do to them, but it doesn't reveal like your research question as a scientist, because if you told them absolutely everything, then they might behave differently than they would otherwise. So we can't just tell them absolutely everything, like we're interested in studying the sales of ice cream and blah, 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 blah. Would you be more willing to buy ice cream during the hot summer? Well, us telling them that we're interested in that might influence their answer. So instead, the consent form for looking at whether people buy more ice cream during the summertime would be, a consent form would say, you're about to answer some questions regarding behaviors that you might do during these months. All it's going to be is just answering questions from 1 to 7. So you're basically telling them their actions, but you're not telling them the whole motivation, and that's on purpose, and that's okay. We have never seen any evidence of causing a lot of psychological trauma or damage. The debrief form now does tell them the intention of the scientist, and this allows the participant to read our intentions and to say, okay, I don't want my data to be included. I don't want anything to do with this. Shred it, and then we have to shred everything they just gave us. It also tells them that we keep them completely anonymous. If we did research on a particularly sensitive topic, then we do assure them that we're going to de-identify their data, which means we separate their name. We basically give them a number that has no association to anything. It's a random number, and then their data point is known by that number, and their name is completely deleted forever. So that's what the debrief is telling them and ensuring them, and we give them all the contact information. And if they experience any sort of psychological tension or anything like that, we give them on these forms, we give them links and resources that they can address in case they feel they need to talk to someone. And we just take, if a design is particularly stressful, we do follow-ups with them to make sure that they're still doing fine and everything like that. Because at the end of the day, we care about humans. That's why we're doing this research. So we obviously care about our subjects as well. So step one is getting this past IRB. You need approval first. We can't just design an experiment and just do it, because like that is illegal. That's super illegal, at least here in the United States, which is where I'm doing research. I can't speak on behalf of every single country because I don't know every single country's law when it comes to doing research. So the next step, after you've gotten past IRB, so most of the time they have an adjustment for you. They say, okay, we're not particularly fond of this question, maybe reword it this way, or we're not really clear why you want to use this. It just seems like added stress to the participant. Remove it, please. They usually want like a minor tweak. Sometimes it's a major tweak, and that just requires you to like redesign it from the ground up and stuff like that, and then send it back to them. But for the most part, it's like minor tweaks. And then once you get their approval, then comes the time that you have to build your experiment. So then you have to say, okay, how am I actually, or you already know how you're going to build it because you've already given the blueprints up to the IRB and to whoever's funding your thing. You gave them a proposal. So then you go ahead and build it. And depending on your experiment, it could be online. So you're building online questionnaires, things like that. A lot of the time, these materials are already built because it's nicer for the IRB to be able to see what the participants are already going to go through. It makes the process much faster, the approval process much faster if you can give them as many materials as possible. So often this is already built, but if it's not, you kind of have to you have to take some time to build your experiment, whether you have to program in a computer or not. Next phase is actually running the experiment. So this right now, for example, we can give an example of what an experiment right now might look like. Right now, it's because of COVID, my lab is closed. I cannot bring in people to do MRI studies, fMRI studies, EEGs, EKGs, nothing. I can't do anything like that because that would be increasing them to a risk where the benefit, it doesn't seem to outweigh the risk anymore. So the IRB would not approve anything like that. Plus, we do have like the laws right now forcing us to close down. Even if the IRB did approve it, well, the law says we can't, and the IRB and us have to obey the law as well. So right now we can't do any sort of research. But that doesn't mean all research is halted. So we just had to improvise and adapt, which the quickest way of adapting is doing online surveys. It's not the best quality of data, but it's still data. We do try our best to control for noise being like variances in our data that could be caused due to people just not paying attention. Like, for example, a lot of people taking our surveys are just sitting there on the couch, like watching TV while they fill it out on their iPad, right? Because they're getting like 10 cents per survey, so they're just trying to burn through a lot of these surveys. So we understand that. It's not like we're oblivious to these things. We're scientists, but we're also humans. We know what people are capable of because we ourselves are humans. That's what makes social psychology really fun, is you can run a lot of your own theories and methodologies on yourself or on your friends and stuff like that. Man, I just really love social psych. I love talking about it too. But anyway, so we understand this. So a lot of our statistical models may try to take that into account, reduce the noise as much as possible, blah, 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 blah. And I'm happy to talk about how you can go about reducing noise and stuff in the stats and how we do it. But that's not the focus of today's talk or little chat here. So right now, a current experiment may just be a survey online, which is unfortunate, but it's not the worst. Like, it could be much worse. So we're not really complaining. We're just collecting a lot of data. Yesterday I was streaming and I mentioned that I had a lab meeting yesterday. Oh, it was so cool. I love my lab meetings because um, we have some very, very prominent social psychologists that attend this lab meeting. They are pretty big names in social psychology. If you Google them, you'll see Wikipedia pages of these researchers. One of them being Marilyn Brewer, another one being Brenda Major. I actually get to work with Brenda Major. We do research together, which is I feel very fortunate to work with her. I mean, I feel very fortunate to work with my own advisor too. He's incredible. I really like my advisor as well, but I do really feel fortunate working with a different scientist such as Brenda Major. And we had just had a lab meeting yesterday, and Marilyn Brewer, Dr. Marilyn Brewer, got to give. She was presenting research, and what she did was she started collecting data on people's donation behaviors during COVID and tracking it. And she's kind of comparing, not really comparing, but she's gathering data in different parts of the world too. So it's really cool to be able to see real-time data just kind of being processed, and we're interpreting it as we live. And so this is kind of how we're adapting right now with our social psychology. Neuroscience part is kind of downplayed a little bit. We can't bring people into the fMRI and scan them, not yet, but hopefully soon. So that's kind of what the next step would be in this research process. How is research done? So you've already passed IRB, you've already designed your experiment, you've already built the experiment, now you're ready to roll. If it's an online study, you basically try your best to put it everywhere you can. We sometimes post on Facebook, like, guys, here's a link, you get $5. We try to think of ways of getting people to want to take these things, like, oh, we offer $5, Amazon gift card, blah, 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 blah. Sometimes you may get that. You may get that email from us, and sorry, but we're really desperate for data, so I apologize, but please do those if it is for a good research cause, of course. I'm not advocating for any link you get and it offers you like $5. No. There are services we can use to really help us boost our reach of who we send our research to. This is, again, I already kind of touched up on it with people sitting at home taking surveys. So Amazon actually offers a service, and there's other services that do this too. But basically, people can sign on to their Amazon account and make money by taking surveys. And so underneath those surveys, they get this long list of different surveys they can take. So this is where we as scientists have to get creative to make them want to choose ours over maybe taking like a Cheetos survey. Like, oh, crunchy Cheetos, yeah. I don't know. So, but we also don't want to be extremely misleading or anything like that. So yeah. So that's some of the services we're kind of resorting to. But normally, let's just say your experiment dealt with. I know I was mentioning the ice cream experiment. That was just to set up kind of an idea. We don't have to keep with that idea. But let's just say your experiment dealt with MRI. So MRI costs a lot because you take up so much of the participant's time that it's really hard to justify to the IRB and to the participant, like, oh, do this for free for us. So typically, participants are getting paid like $20 the hour, if not a little bit more, because our scans can take up to 3 hours. It's really hard to get one scan in less than an hour because we have to do several types of scans before getting to our experimental design that we actually want to run on our participants. So let's just say you want an MRI. So you have to start. And I'm going to explain some steps behind this one just to show you how our research isn't just so fluid. We also deal with day-to-day barriers. So I want to do an MRI study. So I actually have to go to the office, make some appointments, see if there's any openings that I can use MRI because I don't have one myself. And then I kind of slot in myself, make the appointment, be like, all right, cool. And then I have to reach out to the participant, make sure they're available those times, slot them in. So we actually this is why grad students usually recruit undergrads to help us because we need to coordinate a lot of stuff. We need to be coordinating the MRI schedule with our own schedule, with our RA schedules, with the subject schedule, bring them in, with the lab technician. So usually there has to be someone that works the MRI to be there with us, just as a safety measure as well. Usually we don't like to leave one person in there by themselves. So we have to coordinate a lot of different schedules. So having a team to help us coordinate all that is nice. Plus, as a graduate student, we have to go teach people. We have to go teach classes. We have to take classes. We're doing homework. And we're also trying to do research. So right now, if you were trying to do some research, you would just basically launch it, and in the same day, you could actually finish data collection. I've launched a study and within 2 hours, gotten over 1,500 responses, which was enough for that experimental design. We were only looking to get 1,000, and so no, we were looking to get 1,500. Yeah, we were looking to get 1,500. We got it within 2 hours because you set the parameter. You say I want this many, and then it just stops at that threshold. It doesn't overshoot it because you're paying per participant. I'm gonna actually, I've noticed I haven't stopped to give like 30 seconds just in case I'm going too fast and people have comments or anything like that. I don't know. I'm gonna give it 30 seconds while I drink some water. Okay. So, yeah, I was mentioning we launched this study, and then within 2 hours it was already okay, it's done, and you can already start data analysis, data cleaning and analysis, which is the next step. So let's just say you've run your experiment. So again, let's start over. So you had your question, you got it approved by your advisor, you got the funding, they everything's approved there. You send it to the IRB, the internal review board, who makes sure it's humane, everything's good, safe, ethical. They're also checking ethics. They're the people. There used to be experiments like back in the 40s or even 60s even that were incredibly unethical. That could cause psychological trauma. So they're making sure that this isn't happening anymore. So these are those boards. And if you fail it, they ask you to tweak it and stuff like that. So you've already passed that. You already designed your experiment. You launched it. You collected your data. So next step is the data processing. So this part can take, depending on your expertise in statistics and whatever software you use to process your data, it can take you like not minutes, like couple of hours to days. And it also depends on how much data you collected, of course, and it also depends on your experimental design. I keep saying it also depends. I'm very sorry, but that is a thing. And I don't want to just say that everything's the same. I'm not here to generalize processes. I'm here to give my experience as a graduate student and just answer any questions that people might have. So, for the most part, the time it'll take you will just depend on your skill and your knowledge of statistics and your skill in the platform that you're using. So my lab typically uses something called R. I do have resources in my about. My about isn't just about me. It has a lot of resources. I'm happy to update those with any other resources that people may find that help them a lot or they might find that are useful. But down there I have 3 links under statistics. You have where to download R the language. You have where to download R Studio, the platform on which you actually write your R code, your syntax, and run it and get your stats and do all that. R is very cool. It's really becoming the main language that's used for statistics. I do acknowledge that Python can be used, and it probably will catch up and surpass R at some point, but for now we're using R. And I also have in my About Me, under the Science and Education Resources section, I also have a link for YAR, the Pirate's Guide to R. It's a very easy read for learning R for anyone that wants to learn R. That's all down there in my About. And if you're listening to this on YouTube, go to twitch.tv/SharkPartyGG, probably /about if I had to guess the full URL, but just go to my profile, go to my About, go to the Science and Education, and you'll see the links there that I'm talking about right now. Cool. So the next step is data cleaning. This typically has taken me longer than the actual analysis portion because most of the time when you've developed your experiment and designed it and proposed it, you've already had to propose how you would do your data analyses, but you haven't fully said how you're going to. You do usually propose some sort of method of cleaning, but you don't go over every single step. You just say your proposed analyses. That way people can kind of review whether you're going to be like biased in your analysis, because there are a lot of ways of biasing your stats to say things that you want to say with the math correctly checking out, but you kind of manipulated your mathematical models to make a message that you wanted to say, and that didn't necessarily, the true data didn't necessarily reflect. So data cleaning involves the process of going through and trying to get rid of anything that doesn't belong. This can be like, let's just say you sent out a survey to 100 people and you see out of those 100 people, 10 of them didn't finish it. What do? You can't just guess on their behalf. You can't randomly choose either. So you have to throw them away. That's unfortunate. This is why we know this, and we have to do what are called power analyses. A power analysis can help us determine how much data we should collect to ensure, given these constraints, the fact that we're going to have to throw away data. That's just something we have to accept. Given that, how many people should I collect for this type of experimental design? That's called the power analysis. And power analysis can also be used for other purposes as well. But in this case, what happens with those 10 data is we have to throw them away. So that's kind of a step in cleaning, is you have to trim away the data points that don't belong, that truly don't belong. And this is again where people can show bias, and that's where we as scientists need to strive to show as little bias as possible. And this is why we get other people to review our statistics, to also run their statistics, because if we can't get the same thing you're getting with the numbers you've provided, the data you've provided, then there's something sketchy going on. And so there are people that can double check these things and be questioning these things, so that way we minimize bias as much as possible in science. So the next step in how the research is done is you have to clean your data to get it down to the data that actually has value to it. I don't want to say the data that matters, because that sounds like it's biased. No, the data that actually has value, the people that actually took the survey that you may have sent out, right? If you had an fMRI participant, what if they were shaking around too much that your image was too distorted, right? You're not going to keep them in the data, because that's just noise. That really impacts your data analyses, because that's not a valid data point anymore. That doesn't fit your experimental design, in the sense that it's just a complete invalid data point. So there is a distinction between a bias and a variable, or not a variable, a data point that truly doesn't belong. So in the cleaning portion, you're just kind of cleaning that out. That's why we just call it cleaning. The data process involves actually running the statistics and getting the numbers, and then interpreting those statistics or those numbers. So here's where you find out if your predictions, because as a scientist you should make predictions before you actually run your experiment and do the statistics. You should have a prediction or a hypothesis. So here, it's the fun part for a lot of scientists. So the cleaning part, we're not, well, at least I'm not super motivated to do it, but what motivates me is the thing that comes after, which is doing the stats, because then you get to find out, did my experimental design, was it right? Did my prediction regarding as the temperature increases, I predict a positive correlation or a positive relationship. As one increases, the other one increases as well. So ice cream sales, I predict, will also increase, and I can also predict to what degree, like the strength. So per degree, how much more money is ice cream going to make, for example. You can predict it like that and see how accurate you are, and that's what statistics can tell you. And so this is kind of like the fun part. We can play with stats, and we can call it, like, I can slice the data this way. So what if I wanted to look at the data based on gender? I could say, okay, well, who bought more ice cream? Let's see. But this is the things that scientists has to think about before they run the experiment, because, like, what all questions are you going to want to know on top of your main question? Like, are you going to be interested if there's a gender effect? Okay, then ask on your survey for their gender, right? Are you going to be interested in a cultural effect? Are you going to be interested in a height effect, in, I don't know, eye color effect? You could collect all sorts of data, but you have to balance how long your surveys are going to get, how much fatigue your participants might experience. You have to balance a lot of stuff. So as a scientist, you got to be thinking really careful about your questions and which ones should go, which ones shouldn't, which ones are very interesting, which ones actually address important questions, which ones don't, things like that. I'm happy to talk about how we decide about that. I'm still in the process of refining that art, because it really comes down to an art. I don't want to say it all comes down to an art. No. A lot of this is science, but some of it is an art form on how to make your surveys or how to make your experiment almost like enjoyable for the participant, to get the best type of data out of them. That is like a finesse. I don't want to say it's art. It's like there's like a finesse there. Like, after doing it so much, people like Marilyn Brewer, Brendan Mazer have gotten it pretty down to an art form, if you will, to a science form. We'll call it to a science form. So now you've analyzed your data. What's next? Is research done? Sometimes I am very sad to say that, yeah, sometimes we have so many projects. Some of us catch our attention more. We're humans. Sometimes we get really motivated to do one project in the middle of a different one that we kind of bench it. And you might not actually reach that data. You might not even have processed the data until 10 years later. And that sometimes happens. And if it becomes too long, sometimes you have to replicate to see if it still holds. By replicating, you have to redo the experiment the same way you did it originally, as identical as possible. What's up, Banshee? Welcome to Taco Tuesdays. Taco Tuesdays, talking about how research is done. I'm almost at the end of the research process here. And I'm talking about the research process in a um, zoomed out way. So, how's it going? Oh, it gives me a break to take some water. Alright, well, while I wait for him to respond. Oh. Cool. Well, thanks for joining. Appreciate it. I'll put thanks there. Yeah, I'm just trying to chill too. Trying to host some Taco Tuesdays. Yeah, I like Taco Tuesday. It's kind of chill. Friday, the Science Friday, I actually felt a pressure. I was like, oh, I actually gotta be like really accurate in my words because I'm gonna talk about other people's science, not my own like stuff. That's why like Taco Tuesday is really chill to do. I like it a lot, but I think Science Fridays will just take some practice and getting used to. But I'm like excited to do Science Fridays because I really want to share the science that's going on in my department. And well, Science Fridays is going to share about science going on all over the world, but also that science that's going on in my department. Yeah, this Friday I might be camping, so I might have to do a pre-recorded, or might do a live session from like from my campsite. Oh no, I might have to move to Thursday. The talk, I'm actually attending a science talk on Thursday, but I might do it, yeah, from camping. I don't know. We'll see. We'll see. But yeah, right now I'm talking about science. Sorry, how research is done. And the final steps here. So I was mentioning how sometimes we are kind of done at that data step. Sometimes that happens that you just get so tied up in life. Like scientists have lives outside of science too. Sometimes they might have a kid. They might get married. They might do X, Y, and Z, and their life kind of takes over. They might switch jobs. They might switch what's it called? Like interest in research altogether. So sometimes a lot of these projects just kind of sit there, and that's unfortunate. There's a lot of data that we could kind of do something with, but that happens and that's life. But let's just say you do like, no, I'm really motivated to continue. So what's the next step after you've kind of processed your data, you did the data analyses, you have very good effects. So if they're kind of weak, you might be inclined to redo your experiment, do another one, maybe get even more data. Sometimes your data that might suggest like, hey, you're onto something, but you really needed to collect more data for us to really be confident to generalize something. Sometimes that's what our statistics tell us. It says like, dude, you're trending. Like we call it, you're trending on significance. Which I'm super happy to have a Taco Tuesday on statistics, so people like can generally understand when they're maybe listening to the news and stuff, to make sense of it really fast. I have tutored stats before, and I give like a crash course on stats, and then it's I don't know. I feel like it can make reading certain things when it comes to stats a little bit nicer. But anyway, sometimes your data, your own data, say, hey, you're really close to finding something. Maybe if you had collected like 200, this is what a power analysis can tell you. It's a different mathematical like model and formula that can output like telling you if you had collected this many more people, you may have found something. So sometimes that happens, but sometimes you get really strong effects. Just like if you did an experiment on saying, oh, I predict that 10 out of the 10 times I have my guitar pick here that I drop it, it falls. Well, that's a really strong effect. 10 out of 10 is super strong. If it was only 2 out of 10, they'd be like, okay, maybe I should run it like 1,000 times, because then it could be 802 out of 1,000 times. Then that's pretty significant. That's pretty good. And it could just be that the first 10 throws you just had bad luck. This is why in stats you have to collect a certain amount of data before you can really be confident in it, because otherwise it could just be due to pure random dumb luck, and we know that. So our experimental designs like know this, and that's why we have to collect a lot of data. The more data we have, the better. So let's just say you got an experiment and you collected enough data and everything came out awesome. Yeah, you can also, if you're So this is what MRI people have to do. People in neuroscience, they have to alter the strategy because we're severely limited by the number of participants we can recruit because it costs us so much. So ideally, in an ideal world, you would want to collect thousands and thousands of brain scans, but time and money just do not permit. It costs us like to run like 40 participants, and then MRI would be like $30,000 or $40,000, and then just the time alone, it takes like 3 hours to do a scan on one person. So imagine running 3,000 people. That's 3,000. That's just way too much for one study. So you have to strategize, and you have to really make your experiments as potent as powerful in terms of your effects and your theory. You want to test out really strong effects and predict really strong ones. You don't want to go with weak ones. Those are better saved for behavioral designs that are much cheaper. If that's not making sense, just let me know. But like, I think this is what you might be talking about when it comes to altering your strategy. But like, we alter our strategy in terms of like what we're going to collect when it comes to MRI. Or like we might spend a lot more time making sure that our predictions are based on a lot of previous evidence, because we're not about to invest like $40,000 into something we have no idea. That's like better for experimental psychology, where you can use like surveys and stuff to kind of poke around a little bit. It costs you 50 cents per survey instead of like $60 to $100 per participant. So back to I don't know if that answered your question or not, or if that addressed even close to what you were thinking. Okay, cool. Yeah, so that happens all the time. Also, another reason to rethink your strategy in your experimental design is because you want to answer different questions. So you want to find out if your original question still holds, but at the same time, why not answer other questions at the same time? So that's another thing we can do that makes our scientific process way more efficient, and it's still equally as valid. So let's just say you've gotten awesome effects. You're like excited about these data. Now what? Well, now comes publication. Now comes another hard step. So publication is the process of writing everything down into a formalized manner. We have a formatted manner, a pre-designed manner that we have to write. We can't just write any way we want. We have to write it in a very template format because there's a specific way science needs to be written. Otherwise, it would be chaos. Because if science's pursuit is to find out the truth, then if anyone wrote it anyway, then it can be heavily misconstrued, and then truth is just out there being like playing a game of telephone, if you will. Like as kids, we played telephone where one person would say something, by the time I got to the end of the room, it was completely different. This is what's happening in our society right now with news. When they read science and then report it one way, and then someone tells their friend about what they heard on the news, this is what's happening, and there's massive misconceptions regarding science, and this is how it can get really out of hand. So we try to write in a standardized manner that's very predictable. That way people can more easily digest it, but it also makes it easier for scientists to be like, all right, you're missing a conclusion. Like, what's your conclusion? Like, we are used to reading certain ways. That way, when we approach an article, we know what to expect, and we can more so focus on the science at hand and not their like sloppy writing or their grammar or stuff like that. We all agree on like a certain way. Now, different institutions, different fields agree on different standardized formats, but nonetheless, they have their standardized format. Ours right now in the journals I write for is called the APA format. If you're in college, you may have heard of APA or MLA. Yeah, ours is APA. It's a lot of torture, but in the end, when you write so much, it actually ends up being a blessing, because now you're so used to writing in a template format that your next papers become much easier to write. Instead of starting from scratch every single time to write a paper, you just already have a template, so it's super nice. The next step is publication, and this step requires a lot of work and motivation because it's writing, and so there's no deadline on this. This is why as a graduate student, sometimes it's very tough because it requires so much discipline on your side, because you have to sit there and find time to do writing while you have homework, while you're teaching, while you're trying to do your own jobs, while you have your hobbies and your own personal life. This is why we say we're kind of busy as graduate students, because we always feel a pressure to be writing. But we're actually some weeks we're actually not that busy, but we feel cognitively busy because we're constantly thinking like, man, I gotta really write this publication. I need to get published. I need to write this thing, and that task of writing a whole paper is pretty big. You have these papers get really tough to write because we have to write the literature review, so what already exists on that topic. You have to write what you did, and you have to list it step by step. It's like a cookbook. We have to write a recipe to our experimental design, so other people could, if they wanted to do it, they could do it and get the same stuff we did. Because if they don't, then someone lied somewhere. So the middle parts of our writing here is called the method section. And basically you can think of it as like a recipe. This is the recipe. This is how I did it. These are the materials I used. This is at what temperature I ran it. For example, if you're doing that experiment on ice cream and sales, this is the temperatures I use. This is the thermostat I use. We report as much detail as we can. That way when people replicate it, they can get the same results as we did. Or similar results. We know we're not going to get the exact same ones, but similar trends as we did. So let's just say you're done writing this whole paper up. Cool. And then, so now what? You just have a cool paper and it's on your desktop. So typically your advisor is the person that kind of points you in the right direction if you're a grad student. But let's just say you don't have the advisor to go do stuff with. But typically you give it to your advisor. They read it because they're probably going to be a co-author with you. It's very hard to solo author a paper by yourself on your very first go, because you're in grad school to learn how to even write to begin with. So your advisor is going to help you a lot on writing your first stream of empirical papers, or other people might be in on it too, like maybe a fellow graduate student in your lab might be a co-author. I'm working on my colleague in my lab is about to do some pretty cool stuff regarding machine learning and fMRI studies and stuff like that, where he wants just to get my help or my opinion on the writing portion. So he's going to grant me co-authorship, which I think is incredibly nice of him. Like, I didn't expect that. Like, I just expect acknowledgement if I'm going to be editing the papers. But so that can happen. So we can get co-authorship like that without ever having writing too. So just remember, when you guys encounter science and you're like, oh, this person wrote about that, sometimes it's actually not them writing it, but they did. Usually the authors at the top listed had some level of influence on the paper, or did something for the whole thing that warranted them getting some credit for it. So your first papers will probably have co-authors. If some advisors might take first authorship. Sometimes that matters. Some advisors don't really care. Sometimes it doesn't matter who's first author. But first author saying like you did the bulk of the thinking and like you did the lifting here. That's kind of what like first authorship. You can kind of think of it. It's not really a big concern to the general public, but within science and for us, like our careers and stuff like that, it can matter to be like, oh, I've been published like 14 times, and of those 14 times, I've been 10 times the first author. That's like pretty good, but it's not the end all be all, right? Like, what if you're an extremely productive scientist that you work on like 20 different like projects, and so you're getting 20 different publications, but 2 of them are mainly yours. That ratio doesn't sound so great of like being first author to not, but like if your volume is immense, then like cool. But also it'll matter where you're publishing. Like if you keep publishing to low impact journals, then it might not look as impressive as if you publish into like the highest journals, like the most prestigious journals. So that also matters for your publications and doing your research. So basically you write up this paper and you're with your advisor working on this paper, and then you have to strategize what journal you want to publish in. That's actually a step. You don't just like say, I did my science, okay, publish it. You actually have to think about it critically. Which journal is going to want this the most that would give us the highest chances of actually being published? So, and then depending on that journal, you might have to write in a specific way. So some journals require certain formats, other journals require different formats. All that fall within the confines of APA, but sometimes they say, oh, put all your pictures at the end or something like that. Or sometimes you know that like if you're applying for a health journal, you probably highlight the theory more that deals with health related to your experiment, even though your experiment also addresses, I don't know, other things like physics, for example, but you just think you have higher chances of getting published in health, then you highlight that and you talk about that more in your discussion and your stuff like that. Your data and your math all stays the same. You cannot change that and skew that based on the journal, but you might want to discuss a little bit more on the bottom when you're kind of discussing the implications and like how your science can be used. There you might want to say, okay, like this can be used for health for all these reasons, versus if you want to publish in a physics journal, like, oh, this can add to the theory of physics for all these reasons and has effects on health. And then you can also mention like how it also influences other fields, but you really want to drive home the point that their science is the one that that you can influence, and that's why they should publish you. So then the next step would be, okay, you've decided where you're going to publish, you send it to them, and then they have a process where they receive it and then they send it to 5 anonymous scientists that are experts in that field to read it and review it, edit it, and say like whether it's publishable or not. You don't get to know who they are, and that way there's no conflict of interest. That way there's no like hard feelings, that type of stuff. And so then you kind of wait, and then you wait on the report. most of the time we get what's called a revise and resubmit. So it is nearly impossible to get a perfect paper the first time for 5 different scientists with 5 differing opinions to all agree and say, whoa, yeah, I totally agree with every single thing you said in there. That's nearly impossible. Sometimes we feel like, oh, I'm going to be like that. I'm going to put in so much work on this that people are going to be blown away. You're trying to impress too many people at one go. It's really hard. So if you're in the process of doing this, don't put that pressure on yourself. Just know that this is it's like you're going to get a revise and resubmit, and that's okay, and that's actually normal. Sometimes when you're like a lot of the some of the scientists I work with, they already have super huge names. Like they are the experts, so they send it to people that actually ask them questions. So sometimes they might not get a revise and resubmit if the article is very straightforward, and it's just kind of like there's no reason to revise and resubmit some of those. But not all science is like that. So let's just say you get the revise and resubmit. So your job is to then take into account their edits, their suggestions. Sometimes they might suggest something that you fundamentally disagree with, and you just go, sorry, I fundamentally disagree with this. I guess I'm not getting published. But that's your job as a scientist. Your job is to try to promote truth. So if you think that they're inherently wrong, that's okay, and you kind of got to stand up for you. At the end of the day, we're just scientists trying to figure out what's going on around us. So this is going to happen. Someone's going to disagree with you, and that's okay. But let's just say there's no fundamental disagreements. Then you address their edits. You go, oh, yeah, that makes sense. They did find, like, yeah, they criticized that, and that makes sense. I didn't really see that, right? And that's the point of this process, is to make sure that the science being published and the science being put out to the public is at its absolute best, or as best as possible, that it isn't just one person's opinion and that's it. There's a long line of systems and checks here, starting from your experimental design being scrutinized all the way up to being published getting scrutinized. This is why I always make that joke with, like, all these steps we have to take just to publish, for some guy on the internet to say, yeah, BS. A guy that's never even been to college to say BS. So, like, do you know how much work and scrutiny went into this? And you're just sitting there thinking we're biased and we can just publish whatever we want. Like, do you know? Oh, it's so hard to get published. Oh, I don't want to say that as a demotivational thing, but what I mean is a lot of work. That's the better thing to say. A lot of work goes into getting published, from not just the person trying to get published, but from the community of science altogether. So that kind of ends research, how research is done from beginning to end. Now, where that research goes can be another talk, and we can talk about it now if people want to talk about it, because like that research that is now published, we can take it to policymakers, senators, presidents. We can say, look, here's evidence of this. You should really change policy, or you should take this into account, or maybe inform your people, like make it broadcast. Look, this is evidence, right? This is why when leaders start saying, let's not talk to scientists, like they're wrong, your society might start having issues. So a lot of time we do try to, as scientists, we do try to inform the general public. Sometimes our science is better in the hands of like news than politicians. Sometimes it could be for farmers. It all depends on your area, right? Sometimes it's for astronauts. Sometimes it's for businesses. It all depends on who you're trying to inform. Yeah. So that kind of wraps up how research is done from an eagle-eye view. I was very broad with it. I'm happy to talk about any independent step in super fine detail. But yeah. I'm gonna lurk around for a little bit longer, in case anyone has a question or wants to talk about it, or has their opinion, or maybe their thoughts on what science was done now that they've heard this, like the differences in how they thought it was done. I don't know. I am going to be posting this to YouTube. I'm posting every Science Friday and every Taco Tuesday to YouTube on my YouTube channel. They're all there. Because I know that I think on Twitch, I mean, it keeps these videos on Twitch too, but I think they disappear after like 2 to 3 weeks. So I'm not going to be doing like every single stream to my YouTube, but every single Taco Tuesday and Science Friday are going to be put up on YouTube, assuming there was content and stuff like that. So during any Taco Tuesday or Science Friday, I'm always happy to talk about previous topics if anyone wants to bring them up, because if they had listened to it on YouTube, be like, dang it, that segment was done. It's not going to be talked about for like a year or so. No, we can talk about it whenever. That's why it's called Let's Talk About It Tuesdays, and it's not a specific topic. It's just Taco Tuesdays. Right now, I'm guiding the talks because I'm usually by myself in these chat rooms. So thanks, Banshee, for joining me on this one. And when I say usually by myself in these chat rooms, I know I've only done one other Taco Tuesday, but on my streams too, I'm usually just talking to myself, which I'm okay with too. All right, I'm gonna give it another minute, and if no chats, then I'm probably gonna end the stream here and then start gaming. Maybe stream some gaming to do a post Taco Tuesday discussion. And that way, also, this video won't take forever to download and or to upload to YouTube. But let's give it. How much is left of this song? We'll give it to the end of this song. Oh, this is a long song. No, not the end of the song. We'll give it one more minute. Of course, if there's a chat and discussion, this thing will always go on as long as there's discussion and stuff like that. But I don't want to just have an empty chat room, or not empty chat room, a silent one, because then I'll make the YouTube upload last forever. I guess for now I'm gonna just make some more shoutouts. Yeah, no, that's fine. But if you have, and that's the purpose. Like, the purpose of my channel is also for people that don't know these things to listen. I'm not okay. Let me take a step back. I don't want to put any pressure on anyone to talk. If you don't feel comfortable talking or have nothing to talk about, that's cool. And you want to just listen, I'm happy too. I'm just allowing time. That's what I'm trying to say. Is here's some time for anyone to just chat or to talk. But also, yeah, if you don't know particular things, I mean, you're already asking questions, so I don't think I have to tell you. But that's what this is for, right? But yeah, anyways, I was gonna say, I'm gonna do, okay, so basically, every Tuesday I'm gonna keep trying. My favorite experiment, oh, that's a good question. Huh, shoot, I don't know yet. Oh, man. So, one of my favorite ones I've done is actually not done yet. It's the pilot for that study is already done. And I loved it so much because that was the first experiment where I had complete reign over it, which means like, so basically my first two experiments I did as a graduate student were hand-me-downs. Basically, like the first two studies of this long line of studies they were already done before I got there. So I just kind of picked up where they left off. Yeah. So I picked up where they left off. So I didn't feel too attached to those experiments. Like, they were fascinating. They were awesome. But like, from the personal sense, I didn't feel too attached to it. Versus the one I got to run, and now I'm running a lot more because I have a lot more experience than when I first started off, which was the point behind getting those hand-me-downs, was to like start training me on how to do science without giving me the stress of having to design it from like scratch myself. But the one I got to design from scratch, oh, that was so much fun. That's been my favorite one. And that experiment dealt with kind of your identity, and this is why right now I can't run it, is because I can't do what I wanted to do, was collect saliva samples to do enzyme studies. I was looking into doing blood work to look at more biomarkers, and doing EKGs and possibly EEGs, and collecting a lot of physiological data. But basically the topic was looking at intergroup conflict, so like social identities and clashing and what it does to the physiology of the brain and the psychology. So, unfortunately, that's been paused. But the reason I enjoyed it so much is because that was the first time I got to think of the research question by myself. I just was like, you know what? Like, I wonder why this. Go to the literature, do it all by myself, right? presented to, obviously my advisor was like, oh, you should look into this. Like he's there to help me, be like, you should look into this literature. But it was like the first time I got to design the hypothesis myself, like come up with the predictions, and because I had so much power over it, I felt I could make like 3 or 4 times as many predictions because I fully understood the experiment. Because when I got the hand-me-downs, I didn't understand the motivations behind the experimenters, like what their intentions were. When you actually understand what you're trying to get out of it, you can make your predictions way better, and you can understand your data but you can just understand way more about your experiment, making it that much better of an experiment. So that's kind of why that's been my favorite experiment, was the one that I got to design by myself. Um, and COVID halted it, man. It was also fun because it was actually the experiment you helped me on. You were part of it. You recorded it. That's been my favorite one. If you remember, I had you talk about pizza, like calling a restaurant about pizza and hamburgers or something like that. That experiment. Yeah, yeah, yeah. That one was so fun because I had absolute reign over it. So, um, yeah, pizza, not pasta. Yeah, you remember. Yeah. Um, that's the cool thing about being an experimenter too. You can get your friends to help and stuff like that. They can get involved in research. For anyone else listening out there right now, um, if you are a graduate student, remember your friends can help you on stuff. And if you're not a graduate student but have graduate student friends, you might get asked. So for anyone listening to this, I had Banshee, who's in chat right now, voice act some lines for me. I needed to make paradigms where we were manipulating context or framing situation basically around social identities and stuff like that, just to see how if we could impact people's brain physiology, not physiology, but like body physiology, I should go, like enzymes and stuff like that, stress levels, hormones, things like that, based on context. Like see how much power context has over the body and stuff like that. There's so much theory going into it. I love it, and I've had to pause thinking about it. So, yeah, it was such a fun experiment. And it was only a pilot study. And I don't know if I ever relayed the data, but and I'm happy to talk about this in chat or whenever, but all of our predictions were heavily supported. Like we had such strong evidence. But it was just a pilot data. We only collected 100 data points. So what that tells us is we need to redo it, but this time with 300 or 400 participants. And if we get the same results, then we're on to something. And by same results, I mean obviously similar trends. Our predictions are held, or maybe even more supported with even more data. If that's the case, then we're onto something pretty strong when it comes to like just showing evidence for your predictions. Yeah, that's what really is attracted. That's what attracts me to science a lot, is like the creativity. That's why I love music. That's why I love certain things in my life, because it allows for creativity. And I just think that like part of our human happiness as humans, to fulfill it, is we need to be creative in our lives. This is why you kind of have that stereotype of people working office jobs having like really depressing lives. When is their brain when are they allowed to engage in creative thought? This is what I love about music, is instantly you have to engage in creative thought. So like if I'm feeling really stressed and stuff, I don't go run. I don't go do exercise. There's actually theories from a guy from my institute actually, where when you're under high stress, you actually shouldn't be doing strenuous exercise, because you get vasoconstriction, your veins kind of constrict a little bit, which makes circulation much harder, so it puts more strain on your system if you're trying to work out under stressful conditions. It's better to exercise. Exercise is extremely healthy, but it's better to exercise when you're not undergoing like a panic attack, for example. But things like music are an excellent remedy to stress and stuff like that, because they don't put a stress on you that way, but allows your brain to become creative and get your mind off things at the same time. And in a sense, can be therapeutic if you're using music to kind of express yourself. Yeah, that would be sick, dude. I got these guys next to me whenever you want to do a jam stream. And when I said these guys, that's my guitarra, and I got my tenor ukulele here. But I also have my electrics, my acoustic, my bass, and I don't know how I could stream my drum set, but I really want to drum. That's why I just want to finally just drum while you do guitar. Even though I'm a guitarist, like I'm much better at guitar than I am at drumming. I want to have a jam session where I'm the drummer. I just want to see if I can do it. Just like, yeah, I finally got there. That would be sick. I do have the Scarlet. Oh. Huh. Okay, ideas are flowing here. How could we do a jam session? Could stream a jam session. That would be very cool. I do have the guitar cable. I have all types of cables for connecting up to my Scarlett. And it's electrical drum set. It's an electric drum set. So, not too hard. Yeah, actually the delay. What we might have to we'll have to we can test it out before we do a live stream just to make sure that there's no delay because that would be really bad if your sound was delayed and I was trying to set the beat on the drums and there's a delay there. Oh man. Oh man, oh man, oh man. Yeah, hopefully not. I hope not. That'd be a lot of fun though. A Taco Tuesday, let's talk music. And instead of talking, let's walk the walk instead of talking the talk. We'll call it the Waco Tuesday. Actually, we should stream it on a Wednesday. It's Taco Tuesdays, and that Tuesday specifically we'll talk about music, and then Wednesday we'll call it Waco Wednesday, where we walk the walk. Yeah. I'm down to test it. Yeah, we'll do a Waco Wednesday. We'll do a Taco Tuesday. Because Taco Tuesdays aren't intended to only be about science, by the way. Everyone listening, whether recorded or not, I just really want to stress, it's not always going to be about science. I want to talk about travel. I want to talk about music. I want to talk about culture. I want to talk about things that I'm not an expert on too, because that way I want to talk to people and learn from them as well. That's like the purpose of this. This is like a fun place to exchange ideas, thoughts, and stuff like that. I'm exchanging my experiences. I'm never going to be trying to give people like straight up data and teach people. This isn't intended to be, I want people to learn from this stream, but it's not intended to be a classroom. There's a distinction there. So Taco Tuesday is going to be, we could do Taco Tuesday music discussion. So the benefits of music. We can discuss some theory. How math, I like how math is like involved in music and stuff like that. I can maybe bring in some neuroscience of music, like the brain under music, under certain types of music too. So we could do a Taco Tuesday music discussion, and then a Waco Wednesday live music stream. We walk the walk. That would be sick, dude. Taco Tuesday, Waco Wednesday. I like it. I don't know when, but that would be fun. It's a really good idea. Or like a music theme week. I'll do a Science Friday on the science of music. We'll do a Taco Tuesday music discussion. And we can actually, that one would be cool because I've been wanting to interview people on this thing. That'd be cool to get, Banshee here is a musician. He's like way more trained than I am. I don't know. I've been like, when I say I'm a musician, I'm not really, no, not the science of music. You just talk about your experience as a student of, like, you're in music school. Like, I don't know what that's like. I can't talk about it. But what if the listeners are interested in going to school for music, right? It'd be cool that this channel can provide that insight. That's what I'm trying to get at with this channel. Is like, eventually it'd be cool to get other people to talk, not me all the time. But like, oh yeah, you could totally do that too. Yeah, if you know it, of course. But I'm just saying, like, me as a musician, music is my hobby. It's not my expertise. Science is where like I'm dedicating my like cognitive resources to. Music is my means to decompress and stuff. So I can't sit there and tell you like I knew music theory. Like, no way. I can just play and I'll try to jam as best as I can. That's just the way I am with music. So that's what I'm saying. Like, for that Taco Tuesday, you could lead the discussion. The Waco Wednesday will play the discussion, and then the Science Friday will be the discussion of science, and you can totally talk during the Science Friday as well. Do a Science Friday on the science of music. That's awesome. Waco Wednesdays is going to be like a pseudo Mythbusters. That's what I'm realizing. I'm kind of excited. If I could think of other Taco Tuesdays that could lead into Waco Wednesdays, like, all right, you guys don't believe me, Don't believe Newton's third law for every action. No, Newton's third law is, yeah, for every action there's an opposite and equal reaction. Yeah, because Newton's first is a body at rest stays at rest unless acted upon an external force. Whew. So like, you guys don't believe me on Newton's third law? Let's do it, and I'll do a Mythbusters live stream it, and it'll be Wacko Wednesday. We talk the talk on Tuesday, and we walk the walk on Wednesday. Oh, that's awesome. I like that. Cool. Anything else you want to discuss, Banshee, before we end the stream? Anything else we want to talk about? Cool, cool, cool. All right, in that case, I'm going to thank everyone here for listening, stopping by. Just seeing the like on the recording, it shows like number of views. Just seeing that not be 0 just continues to motivate me to talk to an empty room when people aren't here. I'm gonna give a shout out to Banshee again. Thanks for joining me. It always makes these a lot more enjoyable, and a lot more engaging. And I just want to show people that you guys should do this too. I encourage anyone to join these chats and talk. And if you have something you want to share with the world, I'm happy I'm trying to build a Discord around this. I'm happy to build a Discord to be like, so to speak, interviewing people on my Taco Tuesdays and Science Fridays, and possibly Waco Wednesdays. That might become a thing. I don't know. We'll see. Anyways, to everyone that's listening to this recorded, you're a champion. You keep me going. To anyone that stopped by, I don't know how you're gonna hear this. Thank you now, but stop by. Thank you. Yeah. Have a wonderful evening, and thanks for talking about it.